Okay, hello everyone, and welcome back. Today we're going to compare data displays. Compare a couple different data displays, one versus another. Okay? Sometimes we're looking at the same type of data displays compared to another set of data. Sometimes it's the same set of data with two different types of displays. All right, today's objective is to analyze and compare the shapes of different data displays. All right, different sets of data. Today's essential question: how can we use data displays to compare different sets of data? All right, that's what we're going to look at today. Compare two different sets. Again, the shape of a data display can tell us a lot about the set of data. We looked at that yesterday. But we can compare the shapes of two data displays to help us compare two different sets of data. All right, as an example, these are two different cars and we collect data from them. Which car should we buy? Again, most of these are really quite obvious. All right, if we're looking at highway fuel efficiency, if that's what we're interested in, and that's the only thing we're measuring here, Type 2, look at the Type 2 car. It consistently has a higher fuel efficiency than the Type 1 car. This has an outlier way out here. All right, this has an outlier too, but this one's much higher. All right, Type 2 is a better car to buy if highway fuel efficiency is the thing you're looking for. All right, here's two different schools, Caitlin and Phillips. They raised some money. All right, which school raised more money? All right, if you notice, the range is the same. The minimum and the maximum is the same for each school, Caitlin and Phillip. However, look at Phillip. His median is higher, and 50% of the data, remember, is inside this box right here. Versus Caitlin, 50% of her data is down in here. All right, Phillip's school raised more money. All right, which show is watched by viewers who are 50 years old? Show 1 or show 2? All right, look at show 1, doesn't even go up to 50. So here's the 50-year-olds right up here. All right, show 2. Again, if you're advertising, let's say AARP or something like that, all right, or some sort of a retirement plan, you want to advertise in show number 2. Guys, I want to notice one thing about viewers in their 20s. Let's look at each one of these, show 1 and show 2. Now, show 1, there is no viewers between 20 and 24. But between 25 and 29, there's 8 viewers. Okay? Look down here at show number 2. All right, between 20 and 24, there are 3 viewers. And between 25 and 29, there are 5 viewers. That's also 8 viewers. All right? So if you're looking to target viewers in their 20s, you need to be aware. Are you looking for like older 20s? Are you looking for people who are like 25 and older? All right? These have kind of a nuance here. It's not always an exact answer. You need to look at the data. It's not like the answer where you look it up in the back of the book, where the odd ones have answers. Sometimes you need to look closer at the real world. There are different nuances. All right, let's compare these two. When do students send more text messages, do you think? During school days or during non-school days? Well, based on these two box plots, it looks like non-school days quite a bit more. All right? Even though the minimum is the same, 0 for both, some people don't ever send a text message. All right, but obviously during non-school days, quite a few more text messages are sent by kids, okay? Based on that data. Whether it's true or not, I don't know. Maybe they really send more during school days. I don't know. Guys, I wanted to point out when data is symmetric around the middle, something that looks like that. It's known as a normal distribution, and we're going to be looking at that here soon enough. Guys, the mean, median, and mode are basically the same, or close to the same, when it's symmetric like that. The mean, the median, and the mode are pretty close to being equal. All right, theoretically, they're exactly equal. All right, if it's perfectly symmetric. I also wanted to show you a set of data that has the same mean, the same average, but very different medians. All right, look at this set of data A here. All right, look at there's this one outlier way up here. Here's the set of data, 32 is the outlier. All right, versus set B, which is a little more clustered together. Guys, they have the same average. All right, so to describe set A using the average, using the mean, is not a very good way to describe that set of data. The average, it's 8. It's the same as this one down here. Okay? So just be aware of that. All right, there are other ways to describe data besides just the average. The mean's important, don't get me wrong, especially in a normal distribution. But when the data's all over the place, you want to take a closer look at it than just the average of the data. All right, guys, again, the assignments today, there'll be 4 assignments in class. Today's warm-up is a little different. It's matching, all right? You're going to match the proper types of displays with a description, and there'll be sets of data, all right, and displays, and you got to match up the set of data with the display. Okay, that's it, y'all. Thank you very much just for listening. I appreciate it. We'll see you in class.